What I have in my hand is a leaked copy of the final for Calc 1. If you want to watch me solve this, smash the like button and join me in the simultaneous. Alright, so like I said in the intro, I'm going to be working through this final exam. The questions are going to be in the description, so please attempt the final exam on your own before watching this video. But yeah, so I'm going to try to do a few. Start with limits, work our way down the line. Maybe take a break for lunch along the way. Let's see what happens. Okay, so let's start with 1A. Some of the longer questions, I'm not going to write them down, so you should just, I'll write out the solution, but I'm not going to write out the whole question if it takes too long. But this first one, we can. So this is the limit as x goes to 4 of x squared minus 7x plus 12 over x to the third minus 16x. Okay, so the first thing you should try to do is just plug in x equals 4. But if you did that, you would get 0 over 0. So that's not going to work. What we could do is we could factor the numerator and the denominator. And cancel out anything that cancels out. And what's left over? When we plug in x equals 4, we get 1 over 32. All right. So far, so good. Next, we're starting off with a few limits. Okay, so the next one is the limit as y goes to 3 of 1 over y minus 1/3 over y minus 3. And again, if we tried to just evaluate this limit by plugging in y equals 3, we would get 1/3 minus 1/3, which is 0 over 0. So what we could do is move this y minus 3 from the denominator up to the numerator as a 1 over y minus 3. And then we could get a common denominator here. Okay, and you can see that we have a y minus 3 in the denominator and a 3 minus y in the numerator. Those cancel out to give us negative 1. And then we could plug in y equals 3, and we get negative 1/9. Next is the limit as x goes to 4 from the right of 3x plus 1 over x times x minus 4. And here if we plug in x equals 4, we would get 13 over 0. Okay, so this limit doesn't exist, but we could check if it goes to positive or negative infinity. And the way we do that, so we're plugging in 4 from the right. So we're using a number a little bit bigger than 4. We'd have a positive as our numerator and a positive in our denominator. So that's going to go to positive infinity. The last part for these limits is the limit as x goes to 4 from the left of 3x plus 1 over x minus 4. Again, if we plugged in x equals 4, we would get 13 over 0. So we'll plug in a number slightly smaller than 4, right, because we're taking the limit from the left. That's going to be 13, a positive, over a positive times a negative, which is negative infinity. All right, on to question 2. We want to show that the function f of x equals 2 over x minus x plus the square root of x has a root on the interval 1 to 4. Okay, and the way we show that a function has a root is we're going to use the intermediate value theorem. And in order to use the intermediate value theorem, we should first say, well, our function is continuous on our interval. Since a rational function is continuous on its domain and a radical function is also continuous on its domain, and then x is continuous everywhere, we know that it's continuous on 1 to 4. And so what we want to do is we want to find where our function goes from positive to negative or from negative to positive. And if we could do that, we know that at some point it has to cross the x-axis. Okay? So a good place to start is just use the endpoints. If that doesn't work, well then maybe try the middle of the interval. So let's start with f of 1. That's equal to 2 minus 1 plus 1, which is definitely positive. We don't care what the number is, we just care if it's positive or negative. F of 4 is equal to 1/2 minus 4 plus 2, and that's negative. Okay, and so since f is continuous, and goes from positive to negative, the IVT says there must be a spot when f of x equals 0. So there must be a number c in the open interval 1 to 4 such that f of c equals 0. All right, that wasn't bad, right? Good application of the intermediate value theorem. Okay, on to question 3. First it says, state the limit definition of the derivative. Okay, that's an easy one. That's just the limit f prime of x is equal to the limit as h goes to 0 of f of x plus h minus f of x all over h. I guess this is part A. And then for B, we want to use this definition to find the derivative of f of x equals 3x minus 8. Okay, so we want to find this derivative using the limit definition. We can find its derivative using the power rule, and we know the answer is going to be 3. So if we get 3 as our answer, we did something right. So f prime of x is equal to the limit as h goes to 0 of 3 x plus h minus 8 minus 3x minus 8 all over h. And this is equal to the limit as h goes to 0. We could factor out this 3, or distribute it out, sorry. 3x plus 3h minus 8 minus 3x plus 8 all over h. The 3x cancels with the minus 3x. The negative 8 cancels with the plus 8. We're left with the limit as h goes to 0 of 3h over h, which is equal to 3. Sometimes, once you cancel out the h's, there's still going to be some h terms left over, and then you would have to actually evaluate the limit as h goes to 0. But here, all the terms with h's got canceled out. All right. So far, so good. You should keep track of how many you get right and how many you get wrong while you're doing this, so you could kind of have a sense for how you would do on the final if you took it today. Ideally, the more you practice, the better you would do on this kind of test. Okay. So this next question is: find an expression for the area under the curve y equals x on the interval 0 to 3. We want to express this as a limit, and then we're going to use this identity. The sum of the first n integers is equal to n times n plus 1 over 2. We're going to use this identity to evaluate the limit. Okay, so basically what we're going to be doing is taking our interval from 0 to 3, breaking it up into a bunch of subintervals, taking sample points along the way, and then using the limit definition of the integral to find the area. Okay, so we need delta x, which is 3 minus 0 over n. We need x sub I. These are our sample points, which is in general a plus I delta x. So a in this case is 0 and delta x is 3 over n. So x sub I is equal to 3i over n. And we need f of x sub I. Our function is y equals x. So f of x sub I is 3i over n. All right, and that's the hard part of this question, or the hard part of the beginning of the question. So our area, the area under the curve is equal to the limit as n goes to infinity of the sum from I equals 1 to n of f of x sub I times delta x. Right, so this is answering the first part. Express the area as a limit. There it is. Now we want to evaluate the limit. So this is equal to the limit as n goes to infinity of 9 over n squared times the sum from I equals 1 to n of I. This, we are told, is n times n plus 1 over 2. Okay, so this sum is equal to the limit as n goes to infinity of 9 over n squared times n plus 1 over 2, which is equal to the limit as n goes to infinity of 9n squared plus 9n over 2n squared. And this is a rational function in n with the same power in the numerator as the power in the denominator. So the way we evaluate this limit is we could just divide leading coefficients, and we get 9/2. And the way you could check your answer is you could evaluate the integral from 0 to 1 of x dx, right? That's the area under the curve from, 0 to 3, sorry. Our interval is from 0 to 3. And that's x squared over 2, evaluated at 0 and 3, which is 9/2. So we did it right. All right, and this was number 3. Sorry, this was number 4. Flying along, flying along. Okay, number 5. Five says, let y equal the integral from x squared to 3x plus 2 of cosine squared t plus 1 dt. And we want to find dy dx. All right, so the way we do this is we're going to obviously use the first fundamental theorem of calculus. We should break apart our integral, though, so we can actually use the first fundamental theorem of calculus. So this is equal to the integral from x squared to 0 of cosine squared t plus 1 dt plus the integral from 0 to 3x plus 2 of cosine squared t plus 1 dt. Okay, so this is y. And in order to use the fundamental theorem of calculus part 1, we need to have our function of x in the top part of the integral and the constants below. So to do that, to flip the bounds, that comes at the cost of a negative sign. Okay, now we're ready to take the derivative of each of these. So y prime is equal to negative cosine squared. We replace every t with x squared. And then we multiply by the derivative of the function here. So times 2x. That's the chain rule. And then, so that's the derivative of this first part. The derivative of the second part is plus, I'm going to just draw it in the next line so I have space for the next questions. Plus cosine squared 3x plus 2 plus 1 times the derivative of that function, which is 3. So the derivative of this integral is this expression here. All right, let's keep it going. Question 6 is just evaluating a bunch of integrals. So even though we did that at the end of the semester, it appeared at kind of the beginning of this final. So we want to evaluate the integral of x plus 1 times x plus 2 over the square root of x dx. And how do we do this? Well, let's multiply out the numerator, and then we could break it up into a bunch of simpler terms. Okay, so this is x squared plus 3x plus 2 over the square root of x, or the integral of that. X squared over the square root of x is x to the 3 halves plus 3x to the 1 half plus 2x to the negative 1 half. We can integrate each of these terms using the power rule. So it's 2/5 x to the 5 halves plus 3 over 3 halves is 1/2 x to the 3/2. 2 over 1/2 is 4, so plus 4 x to the 1/2 plus c. Right, we have an indefinite integral, so our answer should be an entire family of functions. So we should have a plus c at the end. All right, next we have another integral, this time with some trig functions. It's the integral of 4 minus 5 sine to the 3rd x over sine squared x dx. We don't know how to take the integral of a quotient, right? We don't know how to take the integral of a quotient, so we should do kind of the same idea as we did here. Let's take our fraction and break it up. So that's the integral of 4 over sine squared of x dx. Or I guess we don't have to break it up that far. Minus sine to the 3rd x over sine squared is just sine of x. Okay, and this 4 over sine squared of x is the same thing as 4 cosecant squared x. Okay, and we know how to evaluate the integral of cosecant squared. That's negative cotangent. So this is equal to negative 4 cotan of x. And the integral of minus 5 sine of x is plus 5 cosine of x. Oops, not dx, we just took it the integral. And then again, this is an indefinite integral, so we have plus c. And we have one last integral question. Maybe there's more later on in the test. But for this question 6, it's the integral from minus 1/2 to 10 of the 5th root of 2 plus 3x dx. And so the way we'll solve this is by using u substitution. So we'll let u equal 2 plus 3x. So du is equal to 3 dx. Or another way to say that is du over 3 is equal to dx. And then our bounds, u of negative 1/2 is equal to 2 Oh, sorry, I wrote the question down wrong. Usually these questions have nice clean numbers. The integral from negative 1/3 to 10. I mean, if it was negative 1/2, it's not the end of the world. But u of negative 1/3 is 2 minus 1, which is 1. And u of 10 is equal to 32. Okay, so our integral is 1/3, right? That came from here. 1/3 the integral from 1 to 32 of u to the 1/5 du. Okay, and so that's equal to 5/18, increase the power by 1, divide by the new power, u to the 6/5, evaluated at 1 and 32. 32 to the 6/5, well, 32 to the 1/5 is 2, 2 to the 6th is 64. 1 to any power is 1. Okay, so this is equal to 63, 5 times 63 over 18, which would be 35 halves. Okay. I think so far we're doing pretty good on this final, right? I think we're acing it. On to question 7. Find the extreme values of f of x, so this is number 7, equals 1/3 x cubed minus 3/2 x squared plus 2x, and the interval is 0 to 2. Okay, so how do we find the extreme values of a function? We find its critical points, or its critical numbers, and then we test the endpoints as well. So let's take the derivative. That's x squared minus 3x plus 2, and we want to set it equal to 0. We would also want to find where it's undefined, but this is a polynomial, so it's always defined. This factors into x minus 2. X minus 1 equals 0. So we have to test 0, 1, and 2. Since one of our endpoints is also a critical number, we don't have to test it twice. So f of 0 is equal to 0. F of 1 is 1/3 minus 3/2 plus 2, which is 2/6 minus 9/6 plus 12/6 is 5/6. And f of 2 is 4/3 minus 3 plus 6. Sorry, that is wrong. I had all the powers off by 1. 8/3 minus 6 plus 4 So 8/3 minus 2 is 2/3, which is 4/6. So the absolute min is 0, absolute max is 5/6. All right, so we're on to number 8. State why the function f of x equals 2x squared minus 4x plus 5 satisfies the mean value theorem on the interval -1 to 3. And then we want to find all numbers C that satisfy the conclusion of the mean value theorem. Well, why does it satisfy the mean value theorem? F is continuous and differentiable because it's a polynomial. So we're allowed to use the mean value theorem on this function, right? You're allowed to use the mean value theorem for any function that's continuous on the entire interval and differentiable on the interior of the interval. Okay, so now we want to find C such that f prime of C equals f of 3 minus f of -1 over 3 minus -1. Okay, so f of 3 is equal to 9 18 minus 12 is 6, plus 5 is 11. F of negative 1 is equal to 2 plus 4 plus 5 is also equal to 11. So we want to find C such that f prime of C is equal to 0. F of x is 4x minus 4. So we want 4c minus 4 to equal 0, and then we're only going to take the values of c that lie inside of our interval. In this case, c equals 1, so it's in our interval. Okay, so if these weren't the same, well, then we'd have to look at this difference quotient. Maybe it was a different number. So you would take our derivative and set it equal to whatever number this fraction becomes. In our case, we use 0, because 11 minus 11 is 0. All right, that was number 8. I got to remember to write down the numbers. Makes it easier for me to follow along. Number 9. There we go, I wrote it down. Find the critical numbers of the function f of x equals x to the 4/5 times 5 minus x. Okay, so remember the critical numbers are when the derivative is 0 or is undefined. So we need to take the derivative of this function. We might be best off multiplying this out. So we get f prime of x is equal to 4 x to the minus 1/5 minus 9/5 x to the 4/5. And in order to find when this is 0 or undefined, we have to get rid of our negative exponents. Okay, so this is equal to 4 over x to the 1/5 minus 9x to the 4/5 over 5. And now we could get a common denominator. Okay, so f prime of x is equal to 20 minus, we're going to multiply this fraction by x to the 1/5 over x to the 1/5. So that's minus 9x over 5x to the 1/5. Okay, so to find the critical numbers, we have to find both where our derivative is 0 and when it's undefined. So our derivative is 0 implies that the numerator is 0. So x is equal to 20 over 9. So that's one of our critical numbers. F prime of x doesn't exist implies that our denominator is equal to 0, which implies that x equals 0. So our critical numbers are x equals 0 and x equals 20 over 9. All right, let's keep going. Number 10. Find the limit or show it doesn't exist. And it's the limit as x goes to infinity of the square root of x squared plus 5x minus x. So the way we deal with these square roots is we multiply by the conjugate. We might need a little bit more space on this one. And seeing as the next question is a very long question, I'll just use this whole board and then we'll erase it all when we get to the next question. So multiply by the conjugate. That's the square root of x squared plus 5x plus x over itself. Okay, so this is equal to the limit as x goes to infinity. The numerator is x squared plus 5x minus x squared. And our denominator is the square root of x squared plus 5x plus x. Okay, and so this is equal to the limit as x goes to infinity of 5x over the square root of x squared plus 5x plus x. Okay, now if we tried to plug in infinity, you would get infinity over infinity, so maybe nothing happened here. But what we could do is multiply the numerator and denominator by the highest power of x that appears, 1 over the highest power of x that appears in the denominator. Here it looks like it's x squared, but that's inside the square root. So it's actually x to the first. So multiply the numerator and denominator by 1 over x. And so we get the limit as x goes to infinity of 5 over the square root of x squared plus 5x. This is over x plus 1. And since x is positive, x is equal to the positive square root of x squared. So we could bring this into the square root here. We're almost done. This is the limit as x goes to infinity of 5 over the square root of 1 plus 5 over x plus 1. Now we could actually evaluate this limit. That term will go to 0. Everything else will just be as it is, and we're left with 5 halves. Okay, on to number 11. And before we get to this question, number 11, this is curve sketching. If you're new here to my channel, do yourself a favor and watch the video 7 Facts Needed to Graph a Function by Hand. It is one of the best videos I will ever make. Okay, enough build up. Also, if you're one of my students and are watching, let me know in the comments if you watched that video and what you think of it. Okay, so this question is number 11. I don't know if I just said number 10. But number 11, we want to, we're given the function, the derivative, and the second derivative, and we want to sketch it. Okay, so our function was 2x squared over x squared minus 25. Its derivative is minus 100x over x squared minus 25 squared. And the second derivative is 100 times 3x squared plus 25 over x squared minus 25 to the third. Okay, so we want to find the domain, the intercepts, symmetry, asymptotes, intervals of increase or decrease, local max, local min, concavity, points of inflection, and then we put it all together to sketch the graph. Okay, so we'll start with the domain. Here we have a rational function. Right, this is really 2x squared over x minus 5, x plus 5. We have a rational function, so its domain is just basically we can't divide by 0. So x is not equal to plus or minus 5 is our domain. Intercepts, If we start with the y-intercept, we plug in x equals 0 and we get 0 over 25. So 0, 0 is our y-intercept. And to see if there's any other x-intercepts, we would have to find when the numerator is equal to 0. But that's still, again, 0, 0. So the only time we cross either of the axes is the origin. Symmetry. So we evaluate f of negative x. That's 2 times negative x squared over negative x squared minus 25, which is 2x squared over x squared minus 25, which is f of x. So it's even. We're symmetric about the y-axis. Okay, so for the asymptotes, I said we could use the shortcuts that we learned in class. We don't have to really evaluate limits, just because you've done that in other questions. So the vertical asymptotes are when we divide by 0. So that's going to be x equals 5 and negative 5. And the horizontal asymptote, since the degree of the numerator is equal to the degree of the denominator, we just divide their coefficients. So y equals 2 is the horizontal asymptote. If the degree of the numerator was 1 more than the degree of the denominator, then we'd have a slant asymptote. Okay, so now we want to get on to increasing and decreasing. So we want to find when our derivative is equal to 0 or it's undefined. And we'll break up our number line at each of those points. So it's undefined when our denominator is 0. So that's negative 5 and 5. And it's 0 when our numerator is 0, which is 0. Okay, I guess I'll write that out. So this is what the number line will look like. So f prime of x equals 0. That implies minus 100x equals 0. So that's x equals 0. And if f prime of x doesn't exist, that tells us that x squared minus 25 squared equals 0, or x equals plus or minus 5. Okay, so now we want to take some test values. Let's go minus 6, minus 1, 1, and 6. And plug it into our derivative. The denominator is always going to be non-negative. Okay? So we just plug in x equals negative 6 into here. We get a positive over a positive. When you plug in negative 1, we get a positive over a positive. Then we get a minus and a minus. Okay, now we want to check local max, local min. So our function goes from increasing to decreasing at 0, 0. So 0, 0 is a local max. Okay, now we'll do the same thing with the second derivative. So this is concavity. F double prime of x equals 0, that implies that the numerator, 100 times 3x squared plus 25 equals 0. But that never happens, right? 3x squared plus 25 is always positive, so it's 100 times a positive. So this is no solution. And then we got to find when the second derivative doesn't exist. And again, it's going to be the same plus or minus 5. So I'm not going to write that out. So we take our number line, break it up at all these values that we found, and take test points. -6, we plug it into here. We have a positive over a positive, which is a positive. We're concave up. If we plug in 0, we get a positive over a negative, right? 25 over -25 to the third. So that's a negative, concave down. And then plug in 6, you get concave up. And so our graph, we take all of our number lines, break it up at every point we have along the way. We're increasing in concave up, increasing in concave down, decreasing in concave down, decreasing in concave up. Okay, so we can now put it together. Marking the the vertical asymptotes. Horizontal asymptote. We had a local max at the origin. And now we know that it's this shape from -∞ to -5. From -5 to 0, it is increasing concave down. And so it's going to look like this. And we should just check. I mean, the picture isn't perfect, but we had even symmetry. So it should be symmetric about the y-axis. And it is. All right, so now we'll move on to question 12. That was a big one right there, number 11. Question 12 is derivatives. Let's just see if we know our derivative rules. All right, so 12 is compute the derivative of a bunch of functions. First one is f of theta is equal to 2 theta sine theta cosine theta. Okay, so this is a product of 3 functions. But that's okay, we can still use the product rule. So we'll treat 2 theta sine theta as our first. Okay, so it's 2 theta sine theta times the derivative of the second, which is negative sine theta, plus the derivative of the first, we don't have enough space here, plus the derivative of the first times the second. Okay, so now we have to figure out what's the derivative of 2 theta sine theta. And again, we're going to use the product rule. So the first is 2 theta. The derivative of the second is cosine theta. The derivative of the first is 2, and the second is sine theta. Okay, so our answer is minus 2 sine squared theta plus this times, well, we don't have space, but I'll just write it below, times cosine of theta. All right, so this cosine of theta is multiplied to this product here, or this parenthesis here. All right, so that was just the product rule twice. That was 12a. B, h of x is equal to 3x plus 1 over cotan of x. This is just going to be the quotient rule, so this is like 3 points. Bottom times the derivative of the top minus the top times the derivative of the bottom. The derivative of cotan is negative cosecant squared all over cotangent squared. And it's fine to leave your answer like this. No point of cleaning it up if you don't have to. All right, and C is g of x, I guess g of t, sorry. G of t is equal to the square root of t plus cosine of t all to the third. Cosine squared. So t plus cosine of t squared all to the third. As t plus cosine of t squared to the 3/2. And then it's really straightforward to take the derivative. So g prime is bring the power in front, keep the inside the same, drop the power by 1, and then multiply by the derivative of the inside. What's the derivative of the inside? It's 1 plus, well, the derivative of cosine of t squared is minus sine of t squared times the derivative of the inside, which is 2t. All right, so this just took the chain rule a few times, but again, it's really not that bad. All right, let's move on to number 13. So we have a position function given to us, s of t is equal to minus 4.9 t squared plus 19.6 t plus 58.8. Okay, part A says find the velocity. Well, we know that the velocity is the derivative of the position. So v of t is equal to negative 9.8 t plus 19.6. B says find the maximum height that the object reaches. So let's find when the velocity equals 0, right? That's when the derivative equals 0, and then we'll plug that into our position function. So we get t equals 2. And then from here, we plug this into our position function to see how high our object got. So that's negative 4.9 times 2 squared plus 19.6 times 2 plus 58.8, which works out to be 78.4. I guess meters would be our units. Question C is when does the object hit the ground? So we want to find when does s of t equal 0. So when does negative 4.9 t squared plus 19.6 t plus 58.8 equals 0? Well, we could divide both sides by negative 4.9 to get t squared minus 4t minus 12 equals 0. And then we could factor this. So it hits the ground at time -2, so it was at the ground 2 seconds ago and 6 seconds in the future. Okay, so depending on the context, maybe you throw out t equals -2, but it's not clear from the question, so we'll keep it. D is for what positive times is the object slowing down? Okay, so for an object to slow down, we need its velocity and its acceleration to be pointing in opposite directions. So if the velocity is positive, we want the acceleration to be negative. Or if the velocity is negative, we want to find when the acceleration is positive. So let's just plot when the velocity is positive and negative, and similarly with the acceleration, and find when they are opposites of each other. Okay, so v of t is equal to negative 9.8 t plus 19.6. And once it hits the ground, the question is done. So we're going to go from 0 to 6. We're going to set this equal to 0 and solve. We've already done that. T equals 2. And now let's just take a test value from each one of these segments and see is our velocity positive or negative on these segments. If we used time 1, we get negative 9.8 plus 19.6. That's a positive. And when we plug in something larger, we're going to get a negative. Okay, so that doesn't tell us anything yet. We still need the acceleration. The acceleration is negative 9.8. It's always negative. So when are they in opposite directions? Well, our velocity is positive from 0 to 2, and it's negative at that point also. So from 0 to 2, our object is slowing down. All right, and then last, for what positive times is the acceleration negative? Well, we showed the acceleration is always negative. So positive, so 0 to infinity. We don't include 0 because it said positive. I don't think you would lose a point if you included 0, but yeah. Okay, number 14. We are cranking through this. I think you're given 3 hours for this. We're going to do it in an hour and a half, I hope. Throat is starting to get a little bit sore, but that's okay. Okay, find an equation of the tangent line to x to the third plus 2y to the third equals 5xy at the point 2, 1. Okay, so we have the point. To find the equation of a tangent line, you need a point and a slope. We're already given a point. And so to get the slope, we need to take the derivative of this. And since we can't solve for y, we have to use implicit differentiation. Okay, so let's take the derivative of both sides. That's 3x squared plus 6y squared times y prime, right? We're taking the derivative with respect to x is equal to 5x y prime plus 5y. That's the product rule. First times the derivative of the second plus the derivative of the first times the second. Every term with a y prime, let's bring to the left. Everything else we could bring to the right. And we could solve for y prime. Or factor out the y prime. And now divide to get y prime is equal to 5y minus 3x squared over 6y squared minus 5x. And now let's sub in our point. So y prime of 2, 1 is 5. So negative 7 over 6 minus 10 is negative 4, which is 7/4. And so we have a point and a slope. We're done. Y minus 1 is equal to 7/4 x minus 2. All right, number 15 is approximate the cubed root of 8.012. Okay, and we're going to use a linear approximation. So our function, f of x, is equal to x to the 1/3, right? We're taking the cubed root. And we'll take a to be 8. The reason why we picked a to be 8 is we know how to evaluate the cubed root of 8, right? The cubed root of 8 is 2. We need the derivative. And now we need the function and the derivative evaluated at a. So f of 8 equals 2, and f prime of 8 is equal to, well, 8 to the negative 2/3 is 1/4. So this is 1/12. And so we know that the cubed root of 8.012 is approximately equal to 2 plus 1/12 of 8.012 minus 8. Okay, and you could simplify that to 2.001. All right, so that was a linear approximation question. Now we could do an optimization question. The sum of two positive numbers is 16. Okay, so this is number 16. X plus y, these will be our numbers, equals 16. What is the smallest possible value of the sum of their squares? So we want to minimize f, which is equal to x squared plus y squared. Okay, and so we don't know how to maximize or minimize functions of two variables. You'll learn that in Calc 3. But what we could do is we can solve for one of our variables here and plug it into our function. So this tells us that y is equal to 16 minus x. So our function is really x squared plus 16 minus x squared, and we want to find when this is equal to 0, right? That's how we optimize functions, is we find when the derivative is 0 or undefined, and that's a candidate for being a max. Okay, so its derivative, f prime of x, is 2x plus 2, 16 minus x times negative 1, right? The chain rule. You could also multiply this out and simplify if you would like. But this is equal to 2x, this is minus 2x plus 2x minus 32. Instead equal to 0. And we get x equals, well, 4x equals 32. So x equals 8, and y also equals 8. All right, and we know that this is a max. We know that this is a max because, we don't know it's a max. We know that this is a min because the second derivative f prime prime of x would be 4 in this case, right? The derivative of 4x minus 32 is 4, which is positive. So the graph would look like a parabola going upwards. Okay, number 17. So this one, I would recommend following along with the PDF because there's quite a bit to the question, and I'm not going to draw it. So the question says, gravel is being dumped from a conveyor belt at a rate of 35 cubic feet per minute, and it coarsens. Its coarseness is such that it forms in the shape of a cone. The sides of the piles always make an angle of pi over 3 with the ground. Okay? How fast is the height of the pile increasing when the pile is 15 feet high? Okay, so what we want to do is find dh dt, right? That's our goal, is to find the dh dt when h equals 15. Okay, and we're also given the volume of a cone is 1/3 pi r squared h. Okay, and what else we were given? We were given that dv dt is 35. That's an r here. And the last thing that we're given, or it's actually kind of in the middle, is that the sides of the pile always make an angle of pi over 3 with the ground. Okay, so here we have h, we have r. This angle here is pi over 3. So the tangent of pi over 3 is opposite over adjacent, h over r. And let's solve for r because we want to find the derivative of h, right? So if we could get rid of r, our function is just going to be in terms of h's. Tan of pi over 3 is square root of 3. So we get r is equal to, or I guess square root of 3r is equal to h, or r is equal to h over root 3. Okay, and so now we have r in terms of h's. We could substitute that into our volume formula, take the derivative of both sides, and we're going to be done. I know a lot of you are intimidated by these related rates questions, but they just take practice. Okay, so v is equal to 1/3 pi r squared is h over root 3 squared times h. Let's simplify this before we take the derivative. So v is equal to 1/3 times, well, this 1 over root 3 squared is also 1/3. So this is 1/9 pi h to the third. Let's take the derivative of both sides. That's 1/3 pi h squared times dh dt. And now let's plug in the information we were given. We know dv dt is 35. We know h is 15. And we're trying to find dh dt. Okay, and so then we could divide over the 1/3 pi times 15 squared, and we get dh dt is 105 over 225 pi, which simplifies to 7 over 15 pi. Okay, so I recommend, now that I've explained how to do this question, I would recommend pausing the video, going back, erasing everything you've done, and trying to recreate this one, because this is a pretty hard related rates question that we just did. But it's definitely good practice. Okay, well, we're on to the last question. Let's see if I can get a little bit more space so I don't have to erase anything. The last question, number 18. F double prime of t is equal to the cubed root of t minus 3t squared. F of 0 is equal to 2, and f of 1 is also equal to 2. We want to find f. Okay, so the way we find f is we'll just take find the antiderivative of f double prime. We'll find it twice. We'll have some unknowns. We'll use our points to find the values of the unknowns. Isn't it a little sad that this video is almost over? It's funny that probably only my mom is going to get this far into the video. Everybody else is going to give up, but she wouldn't give up on me. No, I hope there are still people watching this video at this point. If you are, say hi in the comments. I always like when I have people when people comment. All right, f prime. Enough of this. F prime. Let's write f. Before we find the antiderivatives, let's get rid of this cubed root notation. So this is t to the 1/3 minus 3t squared. F prime of t is equal to 3/4 t to the 4/3 minus t to the 3rd plus c. Okay, and now we could check, do we have any information about the derivative? No, we don't. So we're going to have to take another antiderivative, or find another antiderivative. F of t, increase the power by 1, and then divide by the new power. We're going to have 9 over 28 t to the 7/3 minus 1/4, t to the 4th plus ct plus d. Right? We have a new constant. These are likely not to be the same number, so we should give them different names. F of 0, well, we plug in 0 for all the t's. We're left with d, and that's 2. Okay? And now we could plug in f of 1, or plug in 1, and we get 9/28 minus 1/4 plus c plus 2 equals 2. Let the plus 2 and 2 cancel. We're left with 0. (9/28) minus 7/28 is 1/14. We get c is equal to minus 1/14. Okay, and so now we have D and C. Let's write out our final answer of the final question of the final exam of Calc 1. Hopefully you all passed Calc, so you don't have to do this again. Okay, so f of t is equal to 9/28 t to the 7/3 minus 1/4 t to the 4th minus 1/14 t plus 2. We did it. We finished the final exam. Now, if you had time, obviously you'd want to go back and check all your answers. But I erased everything, so I can't do that. Let me know in the comments if you made it all the way to the end. I think this was a fun video. Hopefully you found it useful. If you did, please smash the living daylights out of the like button and share this video with some of your friends and classmates. Right? They might find it helpful. Maybe if you're not in the same class, but you know your friend takes calculus, share this with them. Let me know in the comments any thoughts you had about the exam. And let me know about the intro. I was pretty proud of the intro. Okay, well, good luck on your final. I'll answer any questions in the comments, so that's a good place to ask them. But if not, I'm going to end this video. Bye-bye. Make sure to subscribe for more Coffee and Math with Dr. Wesselcouch. Don't text and drive. Bye-bye.